Good morning, students. Today we will do the nomenclature of bicyclo-compounds. Now, what do you mean by the bicyclo-compounds? It has, the common structure. You can say, if I will make a benzene like this, and when I will join this carbon with this through a bridge, so it is the form of a bicyclo compounds. So it has two carbons that joins the two cycles, so 1 and 2, and the line joining the two cycles, this is known as a bridge. So what we call it as a bridge. Okay, now the two carbons in these two rings are known as the bridge head carbons. So this one and this one, these two are known as bridge head carbons. Alright, now what is the basic rule for naming the bicyclo compound? It is that we have to use a prefix, that is a prefix which is bicyclo. As the compound suggests, bicyclo compounds, we have to use the prefix also, the bicyclo, and then you have to add a square bracket. Okay, now we have to count the carbons excluding these two bridgehead carbons. So what is the basic rule is that we have to move from largest chain towards the smallest chain. Let us see. Now this is the first chain, first ring, this is the second, and this is the third. If I exclude this one, as you can see, only one carbon is there. If I exclude these two bridgehead carbons, so this will be under the case of smallest chain or smallest ring, you can say. Now I will focus on these two rings. How many carbons are there? 1 and 2. Similarly, in this case, 1 and 2. So both the rings have the same carbons, same number of carbons. So suppose I will take this one. So how many carbons are there? There are 2 carbons. So I will write 2 dot. Now focus on this chain. We have 2 carbons, right? So write 2. Now focused on this bridge chain. What do you say? You can say 1, 2, 3. No, you have to exclude these two bridge head carbons. So that means you are left with only one carbon here. So write here 1. Alright. Now close the square bracket. Okay. Up to here you can understand. Bicyclo square bracket starts 2.2.1 and square brackets closed. Now you have to count the total number of carbon atoms. Okay. Now count 1, 1, 2, 3, 4, 5, 6 and 7. So there are total 7 carbons. And what is the root word for 7? That is hept. That is hept. So now you have to write here hept. As you see, there are all single bonds here. So what is the root word for single bonds? That is ane, right? So here it will be heptane. So this is the IUPAC name of this compound, that is bicyclo square root 2.2.1 square root closed and heptane. Okay. Okay, now this is clear. So this was your example number first. Now let's have another example. Suppose I will draw like this, and here a benzene. Okay, so as I told you in the earlier also that this is our bridge. So in this case, this is the bridge. Okay, so this and this, these are the bridge head carbons. Okay, So as I told you that you have to use a prefix bicyclo. So write bicyclo. Then what you have to do is write a square bracket. Okay. Now you will say that there is only two chains, this one and this one, but not, no, this is not the case. There is one more chain that I will tell you afterwards. First of all, see the largest chain. According to our rule, first of all you have to see the largest chain. So as you can see, this is the largest chain because it has a 4 carbons. Okay, so you will write 4 dot. Now second chain is this one. Count the carbons 1 and 2. So write 2. Now we will talk about the third chain. As in this case, this was the bridge and this was the carbons, so we have written 1, right? But in this case, there is no carbon within the bridge, right? But you have to write something here. So if there is no carbon on the bridge, then you will write 0. Okay. Now close the square brackets. Now what is our next step? That we have to count all the carbons. So count 1, 2, 3, 4, 5, 6, 7, 8. 8. So what is the general rule to write? What is the root of 8? That is oct. O-C-T. Oct. Now as you see, there are only single bonds here. So we will write in. Okay. So this was the normal nomenclature of the bicyclo compounds, where you have to follow some steps. That is, first you have to write a prefix bicyclo, then the square brackets you have to start, then you have to move from largest chain to the smallest chain, then close the square brackets, then you have to write the root word of the total carbon atoms present. Then you have to see that whether there are single bonds or double or triple, then according to that you have to write the root, that is n for the single. Now we will have another example, like suppose that have a substituent. Okay, so first of all a benzene ring. Okay, and like this. Okay, suppose there is a substituent say methyl group. Okay, you have to follow the same criteria. First of all you have to write the prefix, that is bicyclo. Okay, and then the square bracket. Now tell me what are the bridgehead carbons in this case. That are this one and this one. Now first of all we will have the longest chain. We have to count the carbons of the longest chain, that is 1, 2, 3 and 4. So 4 dot, the smallest chain carbons contain 1, 2, 3. So there is 3. And like in this case, there is no middle carbon here also, so we will write 0 and the square bracket close. Now you have to count total number of carbons, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So what are the root name of 9? That is non. So NON, and because there were all the single bonds present here, so you have to write N. So non-N. Okay. Now what we have to do for the numbering of this methyl group. So there is a rule, you have to just note it down, that the numbering that should be start from bridgehead carbon. Okay, that is BHC, and then you will follow the same criteria, that is from the largest chain to the smallest chain. Okay, so now you can imagine the two cases. There are two cases. You can number from here 1, 2, 3, 4, 5, 6, because this was the largest chain. 7, 8 and 9. In this case the methyl group get the 9 number. Now what is the second case? This was the first case. If you say we can count in another way also, like this, there is a methyl group. Okay, so these were the bridgehead carbons. So if I start counting from here, so what we will see, that 1, 2, 3, 4, 5, 6, 7, 8 and 9. So now in this case methyl group gets the 7 number. This was the second case. So this will be more preferential because methyl group get the least number, and here we will cross this one and we will take this one. So what will be our answer? Because the methyl group gets the 7th number, so we will write 7 methyl bicyclo, rest we will write the same thing, bicyclo 430 nonane. Okay, so this will be the IUPAC name in this case, which include the substitution methyl. Okay, now let's move to the another example, so which is 4th number. Let's have now more than one functional group. Okay, so suppose here is carboxylic acid, OH and bromine. Okay, now according to the nomenclature rule, as you already know, that the priority first is given to the functional group, then to double or the triple bond, which is also a form of functional group only, then last is given to the substituents. Okay, so in this case we have COOH as the functional group and these two are the substituents, and before that these are the bridgehead carbons that joins these two rings. So we will number from here only. As you can see, both the rings have the same number of carbons, so there is no largest and no smaller ring. We will give the preferential to the functional group. So we will count like here. Before that, the thing that you already know, that what you have to write is first of all bicyclo, then the square brackets. Now as both the rings have the same number of carbons, so how many carbons are here? 1 2 3 4, so 4, and 1 2 3 4 we will write 4, and no carbon in between the bridge, so we will write 0. Okay, and how many total number of carbons are there? 1 2 3 4 5 6 7 8 9. Okay, 9, and this one is 10, so we will write deck, and because there is only single bond present here, so we will write in. Okay, so this was the usual thing. Now how will you number these substituents and functional group? First of all, numbering will start from here, because we have to, as I have explained earlier also, you have to start from the bridge carbon and then to the largest ring, then to the smallest ring. But here both the rings have the same number of carbon atoms, so you will give the priority to the functional group. Okay, so 1 2 3 4 5 6 7 8 9 and 10. So what will be our answer? That is 7 bromo, right? 7 bromo, and 10. What is the root for OH? That is hydroxy. Okay, so 10 hydroxy. Okay, then bicyclo, square bracket 4.4.0 square bracket close, decane. And now what is the position of the functional group? That is 3, so 3, and then we will write this is carboxylic acid. Carboxylic acid. As you know, the secondary suffix of COOH group, what is that? That is oic acid, right? That is oic acid. But this is the case when the carbon of the carboxylic acid is included in the chain. Here we haven't included this carbon in the chain, so in that very case we will write full name, that is carboxylic acid. If in case this carbon was included, as in usually IUPAC name nomenclature, we include this carbon, but in case of bicyclic compounds we move from largest chain to the smallest chain, and here in this case this carbon was not being included, so we will not write the oic acid, but we will write the carboxylic acid. Okay, so these is the case when more than one substituent group is present plus there was a function group. I hope this is clear. Now I hope that the topic is clear to you. Let's have some compounds that you can solve it by yourself. You can comment below the answer. What is the answer for these two compounds, bicycle compounds? Okay, so one is this and the second is this. I will definitely discuss the right answer. You just comment down what will be the right answer for these two compounds. Okay, so thanks students for watching the video. If you found this video helpful to you, then please like, subscribe and share. We will meet in the next video. Till then, God bless you and thanks for watching.